With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So today we are going to discuss one question on applications of derivatives. So here in this question we are given that the area formed by the lines between the y is equals to nx plus 1 by n, and the second line is the y is equals to minus 1 by n x minus n, where n belongs to the set of integers and y is the maximum for which of the following options. So here we are given the 4 options and we need to choose among these 4 options, and more than one can be correct. So now let us try to solve this question here. So here we are given this is the first line, this is the second line, and the third line is the y-axis, and we need to find the maximum area. We need to find the area formed by these 3 lines, and that area would be maximum for which of the following 4 options. So here we have the first line. So here we have the first line as the y is equals to nx plus 1 by n. Similarly here we have the second line. So the second line is y is equals to minus 1 by nx minus n. And similarly here we have the third line as the y-axis. So the third line is the y-axis, and the y-axis is x is equals to 0. These are the 3 lines which were given to us in this question. Now we are going to plot all of these 3 lines on the graph. So for plotting the graph we are going to assume that the n is positive. So for plotting the graph we are going to assume that the n is positive. So if we draw the graph here, then let us say that here we have the x and the y-axis. So let us say that this is the x-axis, and similarly here we have the y-axis starting from here. So here we have the y-axis like this. So here we draw the y-axis. So the y-axis would look something like this. So this is our y-axis. Now let us name them. So here we have the origin, this is our x, and this is our y. Now we are going to plot these 3 graphs. So here we have the first graph as this. The first graph is we know that the standard equation of the line is y is equals to mx plus c, and for plotting the graph we are taking this n as positive just for plotting this graph. So if we compare the first equation, then we get the slope of the first line as n, and here we are taking the n as greater than 0. So the slope is positive, and since the slope is positive, so the line would make the acute angle with the x-axis, and here we have the y-intercept as the 1 by n, and since n is positive, so the 1 by n would also be positive. So let us say that here we have the line like this. So this first line is like this. This is the first line which we have drawn here. So this is the first line. So this line is the y is equals to nx plus 1 by n. Here the 1 by n is the y-intercept. So here we have the coordinates of this point as. So let us say that this is the point A. So the coordinates of the point A would be, here we have the x coordinate as 0, and the y coordinate would be the 1 by n, like this. Now similarly we are going to draw the equation for the second line. So here we have the second line as this. So here we have, if we compare this equation with this standard equation of the line, then here we have the slope of the second line as the negative, that is minus 1 by n. So it would make the obtuse angle with the x-axis, and here we have the y-intercept as minus n, that is also negative. So here we have the y-intercept. Let us say that here we have the y-intercept, and now we are going to plot the second line here. So let us say that the second line looks something like this. So this is the second line which we draw here like this. So this is the second line. So let us name this line. So here we have the second line as the y is equals to minus 1 by nx. So here we have the y is equals to minus 1 by nx minus n, like this. And here we have this coordinate. Let us say that this is the point B. So the coordinate of this point B would be, here we have the x coordinate as 0, and the y coordinate would be the minus n, that is the y-intercept. Now we are going to solve both of these equations to find this point. So let us say that here we have the point D. So here let us say that this is the point D. So now we are going to find the coordinates of this point D. So here we have the two equations. So if we solve both of these two equations, then for solving that we are going to subtract them. So if we do 1 minus 2 here, if we do 1 minus 2, then we get here the y minus y gets cancelled out, so we get the 0 on the left hand side, and that would be equals to, here we get the nx plus 1 by nx. So here we have the nx plus 1 by n times of x. Similarly here we have the plus 1 by n minus of minus n, that is plus n. So here we get the plus 1 by n plus n, like this. So this is what we have got. Now from this we are going to calculate the value of x. So the value of x would be, here if we take the x common out, then we get the n plus 1 by n, and that would be equals to, if we get this to the other side, then we get the minus common outside, and it would be the n plus 1 by n, like this. So from this we get the coordinates of the x as the minus 1, because this thing gets cancelled out with this thing. So we get the x as minus 1. Now we are going to find the value of y. So in equation 1 we are going to put the x as 1. So in equation 1 we put the x as equals to 1, and on doing that we get the y is equals to, here we get the nx plus 1 by n. So here we get the nx, x is minus 1, and here we have the plus 1 by n. So here we have the plus 1 by n, like this. So from this we finally get the y coordinate as the minus n plus 1 by n. So here we got the y coordinate as minus n plus 1 by n. So the point D, that is the intersection point of both the lines which we got here, the coordinates of that point D would be, here we have the x coordinate as minus 1, and the y coordinate would be the 1 by n minus n, like this. So here we have the coordinates of this point D as the minus 1 comma 1 by n minus n, like this. So this is the coordinate of the point D. Now we are going to find the area of this triangle, because they were talking about the maximum area for this triangle. So now we are going to find the area of this triangle. So here we have the triangle with these two lines, and here we have the x is equal to 0, that is this thing. This is the third line. So the figure which is formed by using these three lines is this triangle, and now we are going to find the area of this triangle. So for that, here we have the height of this triangle as this thing. So this is the height of this triangle. So let us say that here we have the point M. So the area of this triangle ADB, the area of the triangle ADB, here we have the area of the triangle ADB, and that area would be equals to the half into base into height, and the base would be the AB from this diagram. So here we have the AB into height, and the height would be the OD, which we have just drawn here. So here we have the OD as the height. Now we are going to find the OD value. So the OD would be equals to, if we see this graph, then the OD would be, here we have the x coordinate as minus 1. So here we have this distance OD as minus 1. This is the OD. So here we have the OD as minus 1 from the coordinates of the point D, and similarly we are going to find the AB. So the AB would be equals to, here we have the point A as the 1 by n, and the y coordinate of the point B is minus n. So the AB distance would be the 1 by n minus of minus n under the modulus, because we do not know whether the n is positive or negative. So the AB distance would be, here we have the 1 by n minus of minus n, like this. So if we solve this, then we get the AB distance as the n plus 1 by n under this modulus. So this is the AB distance. So from this we get the area of the triangle ADB as the half into AB. AB is this, and height is OD, that is minus 1. So here we have the minus 1, and here we have the AB as this. So if we solve this, then we get the n square plus 1 upon n, like this. And since this is the area of the triangle, so this should always be going to be positive quantity. So we take the modulus of this entire thing. So here we have this minus under this modulus, so it would get removed when we open this. So here we get the half of, here we have the modulus of n square plus 1 whole divided by n, like this. Now we know that the n square is always going to be positive. So n square plus 1 would be greater than 0. We know that So we can say that the n square plus 1 is greater than 0. Since it is happening that n square plus 1 is greater than 0, so we can remove this from this modulus. So we get the area of the triangle ADB as the n square plus 1 whole divided by the twice of modulus of n, like this. So here we have got this as the area of the triangle ADB. And now we need to maximize this area of the triangle ADB as per given in the question. So for that, here let us say that the area of the triangle ADB is given by the function f of n, and that is the n square plus 1 whole divided by the twice of modulus of n, like this. Now for solving this, since we have taken, when we plotted the graph, we took the n as positive, n as greater than 0. So here similarly we are going to take the n as greater than 0 and we are going to find the f dash n for maximizing it. So now for getting the value of this f dash n, we are going to apply the division rule. So for that division rule differentiation, we are going to differentiate the numerator first. So here we have the 2n as a differentiation of the numerator. So here we have the twice of n multiplied by, we retain the denominator as it is, and since we are taking the denominator, that is in the denominator we have the twice of the modulus of n, and while plotting the graph, since we considered n as greater than 0, so here we have the twice of n as it is. So in the denominator we have the twice of n as it is, we are taking n as positive, minus, here we have the numerator as it is multiplied by the differentiation of the denominator. So the differentiation of the denominator would be the 2. The differentiation of 2n is 2 whole divided by, in the denominator we have the square of the denominator, that is the 4n square, like this. Now we are going to solve this ahead. So if we solve this, then this 2, and this 4 gets cancelled out, and in the denominator we are left with 2. So here we have the 2n square, so it would be the 2n square minus n square minus 1 whole divided by, here we have the twice of n square, like this. So if we solve this, then we get the 2n square minus n square, that is, here we have the n square minus 1. So it would be the n square minus 1 divided by the twice of n square. So this is the value of f dash n. Now we are going to put the f dash n as equals to 0 for finding the critical points, that is for finding those points which get this f of n, that is the area of the triangle, as the maximum. So for that we have the f dash n is equal to 0, that is, here we have the n square minus 1 divided by the 2n square is equal to 0. So from this we get the n square minus 1 is equal to 0, or we can say that the n square would be equals to 1. So we get the n is equal to plus minus 1. So here we are getting the two values of n for which this f of n function, that is the area of the triangle ADB, is maximum, and those two values are plus minus 1. So here we are getting the two distinct values for which the area is maximum. So here we got the two values of n, that is the plus minus 1. Now let us check that which option is the correct option. So here we are given the 4 options, and among those 4 options we have got the two values of n. So this option 2 is correct. We got the first and the second value of n as the plus minus 1. So here we got the plus 1 and minus 1. So the option 1 and option 3 are also correct. But in the option 4 they are talking about that only one value of n is existing. So we got the two values of n, and hence the option 4 is incorrect. So the correct options are the option 1, option 2 and option 3. This is our solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.